glass at that time was not good enough. At the time, it was traditional E or ECR glasses that were predominantly used, and those glasses just simply did not have the performance needed to extend blade lengths. Back then, we were talking about blades that were 30 meters, 40 meters long, and how can you use a higher modulus fiber to get to 45 meters or 50 meters? A lot has changed since then, especially the size of these turbines. But back then, the invention of the first high modulus glass fiber for wind really kicked off a new generation. And OC invented this glass just over 15 years ago. And overall, high modulus glass across the wind industry has really become dominant and has been adopted in spar caps, shells, and root segments. We estimate today that something around 45% or more of all glass fiber that's used in a wind blade is a higher modulus glass product. This has completely transformed the industry. This massive ramp up we've seen over the past decade of gigawatt installations, and of course the drop in the levelized cost of energy over that time as well, has a lot to do with the fact that blades have gotten longer and longer, which is driving up the AEP of these turbine platforms to be able to really drive down the cost of energy. Today, when we talk about onshore blades, right, we're talking about 60, 70, 80 meter blades. And offshore, we're talking about over 100 meter blades, and these will continue to grow. And at Owens Corning, we're trying to think of the materials that is going to drive this performance forward. So we continue to adapt ourselves and grow and evolve with the industry as these things change. You know, being a materials engineering partner is core to who we need to be, and providing the tools to allow our blade designers and engineers and our customers to make better and better blades. Whether it's new glasses, new productivity solutions, whatever can be done to continue to allow them to drive for a reduction in the cost of energy. This isn't just simply mechanical or physical performance either. Thinking about the sustainability of the whole blade and the material system being used, and how can we actually improve that? How can we eliminate waste throughout the whole supply chain? How do we reduce the embodied carbon of a blade? And how do we close the loop? These are big challenges that we see ourselves playing an active role in. And this mindset continues to takes us to the next step. And what comes next within Owens Corning and for the wind industry is driving higher modulus solutions to, again, increase the length of these blades and do it more sustainably as well. So today, I'm happy to introduce our second generation high modulus glass for wind. H2 glass is a new glass that Owens Corning is offering that is now being produced on a large scale melter to really drive this current generation of blades that we're seeing today. This technology has been quite remarkable in terms of being able to increase the modulus of the glass without changing the density off of the first generation glasses. This has led to having the highest specific modulus in a glass fiber for the wind industry. H2's performance, of course, can be leveraged in a few different ways in a blade, and particularly either through our unidirectional fabrics lineup or in our UltraSpar lineup. And UltraSpar is a new offering from Owens Corning. This is where we are seeing a fast growing trend in adopting pultrusion for spar cap planks in the industry to leverage the higher fiber volume fraction. This is a fast growing trend that really leverages more of the fiber's performance and really enables H2 to go to new heights. So as we talk about performance of these products, you know, a lot of it comes down to the modulus number, and scientists and companies like to debate on test methods and what measurement gets you the highest number you can put at a page. Here at Owens Corning, you know, the method we use is the single filament sonic fiber glass modulus, which is the best correlator to performance of the laminate. And with this product, it's a 91 gigapascal glass, and which is about a 5% increase over first generation high modulus glass fibers. And again, this is while maintaining the same density of the glass itself, so driving up that specific modulus of the fiber. Translating this into a fabric, at 55% fiber volume fraction, you're going to be able to achieve a 51 gigapascal performance. And again, talking about a pultruded plank for UltraSpar, this is where you see that higher fiber volume fraction come in at 63 gigapascals of performance. These products collectively are starting to drive a transformation in the market, particularly in China, where we see blades are being designed based on these levels of performance to achieve the LCOE reductions that are really needed now that they have to compete in a subsidy-free market in China. So we see a fast-growing trend of this level of performance, these second-generation high modulus glasses being adopted at an increasing rate. But we're not done here either. We want to keep going and keep innovating. So I'm excited to share a little bit more about H3 glass, our next glass that's in the pipeline here at Owens Corning to really continue to push the performance curve of what glass fiber can really do. So H3 glass will be another 5% increment in performance over the second generation high modulus glasses. That's about a 10% improvement over first generation H glasses. And keep in mind, many people in the industry are still using that first generation high modulus glass fiber. So that is a substantial improvement for what many are seeing today. This performance is really possible by our innovation and our glass science. And our team has been learning over the past 15 years of leading the industry in high modulus glasses, or how to invent and develop new glasses and industrialize them. It's around exploring new fundamental science in these areas. And how do we not only invent glasses, but invent glasses that can scale with the wind industry? One of the common challenges with wind is just the sheer size. And it's not good enough to make a couple kilotons of product. You need hundreds of kilotons of product to be able to actually support the industry for what they need. So this requires substantial investment in R&D and in industrialization technologies to be able to perform these things. And this development is what we're pursuing now to support the blades of the future. So here you can kind of see the portfolio of what this performance really looks like overall. On the left-hand side here, you see the unidirectional fabric of our ultra blade fabrics, and where you see the step change, continued step in performance increase. And on the right-hand side, you see it in a pultruded plank, which again shows how you can leverage the higher fiber volume fraction to continue to improve the overall laminate modulus. In terms of timing, we're starting now to really work with our customers on how we can support them in their design efforts and their engineering efforts for how they could leverage this new material in their blades and in their technology. By the end of this year, we'll be producing new data and also having small samples of product available for our customers to really advance their process in designing and incorporating this new glass. And as we evaluate the adoption rate of this glass in the market, and based on our customers' feedback, we currently plan to have this available by the end of 2022. But in shifting gears as well, as I mentioned earlier about sustainability, it's not just the performance of the fiber that counts. You know, a lot of people within the industry always say sustainability is important, and it's a really good question of how do you actually support these claims. And I think one of the key things is within the wind industry, we're seeing this shift from where it was just okay to say that your products are being used in wind and that your products enable the lighter, longer, stronger blade, and that in and of itself made you sustainable. But that's not really the case anymore. The supply chain matters, the materials matter, the embodied carbon of the blade matters. And so we're seeing a big shift with our customers in the industry and how we think about sustainability. And we see ourselves in the driver's seat of these conversations as well, of how do we progress and advance our sustainability too. So here I wanted to share a few of our goals that we've made as well. So the first one is around reducing our carbon emissions, which is a big goal of reducing them by half our absolute emissions for scope 1 and scope 2, and by 30% our scope 3 emissions. And again, these are absolute emissions, which is a challenge that we're glad to go after and continue to improve upon there. When we talk about waste, we're committing to zero waste to landfill as well. And also this commitment is to working with our customers throughout the blade making supply chain. That can be a rather wasteful process overall when it comes to all the steps in the supply chain and the waste that's created from materials. And then lastly, as it's pointing to this presentation, powering ourselves with 100% renewable electricity. and it's something that we're well on our way to doing. But there's of course more to get to this goal. So these are some very strong goals in what we want to do to continue to advance ourselves and really go into this decarbonized business model of the future, essentially. And to highlight a couple of these a little bit more, one is this renewable electricity commitment, where here on the left-hand side, some people may not be as familiar with our roofing and insulation businesses, but last year we sold over $2 billion worth of products that were made with 100% wind power, which is quite substantial, and that's driven a lot by our US operations that have converted to renewable electricity at a really high rate. And we're looking to expand across the world. Here we also show that our specific plants within wind in Europe are switching to 100% electricity as well. And we'll continue this trend and hope to accelerate this as well. And then on the right-hand side, you see this consortium we're a part of with our industry partners to really go after the end-of-life issue, to be able to create a 100% recyclable blade that can help us close the loop and figure out a solution. Every year, the size of the glass fiber market for wind specifically is in the hundreds of kilotons a year. And if you're putting that much into a blade every year, imagine what's coming off in 20 years from now, 30 years from now. So these solutions are really important in terms of driving and having a sustainable future. So with that, I'd like to wrap up this presentation. Again, we're incredibly excited to announce our H2 and H3 glasses. We're excited to see what our customers and our partners in the industry can do with them. And we look aggressively to the future of how do we rapidly decarbonize our platform and our operations to be able to pursue this sustainability journey in partnership with our customers. So with that, I'd like to take a few questions here. I believe we got a couple minutes to answer some questions. So the first one I see here is around having sizing specific for vinyl ester resins. And yes, so for these new glasses, we'll offer these in kind of the current portfolio of sizings that Owens Corning has for wind, which support epoxy or vinyl ester based resins as well. So another question that I have here is around where these new fibers will be manufactured. So our first set of, for H2 glass, our first industrialization plan and our first melter is actually based in China. As I mentioned earlier, the adoption rate and the size of the wind market in China is large, and the adoption of this glass into their new blade size made the most sense to have our production located in China to support that market. As we continue to see H2 glass grow around the world, we'll of course always reevaluate where we have our capacity and how we can best support our customers. In terms of H3, it's a similar story as we see how our customers adopt this glass and where demand will be and where we need to be to support those customers. We'll evaluate what locations we should produce H3 at. So another question I have here is around what degree do you think H2 and H3 glasses will compete with carbon fiber? So that's a really good question. So obviously carbon fiber from a material performance standpoint is significantly higher still than these glasses on their own from a fiber to fiber comparison. But we really see three things within the industry that really support the adoption of higher modulus glasses when it comes to carbon fiber. I mean, the first one is just sheer availability of carbon fiber for how that industry operates. Capacity increments right in the 1 to 2 kiloton range per line, a lot of capital intensity to invest in those lines. And importantly, it takes a long time to build those lines. And one of the challenges I think we see within the wind industry is just the sheer scale and the speed of being able to expand capacity so rapidly to be able to support this industry. And with the adoption of carbon fiber and more blades, we actually foresee a real capacity crunch in the carbon fiber industry, call it in the next 2 to 4 years, that we really think will drive the blade designers and engineers to try to more smartly engineer blades to reduce the overall amount of carbon fiber in those structures, given that challenge. And that leads to point 2, which is we think the price of carbon fiber will continue to be a challenge for its adoption in wind, given the limited capacity, given its demand in other markets outside of wind, within the new hydrogen economy, within other applications. I think it'll be challenging to get low-cost carbon fiber within the wind industry. And then third, again, it's really around sustainability. When we see our customers caring more and more about the embodied carbon of their blade and carbon neutrality, we see it as a challenge with carbon fiber because of being pan-based. Carbon fiber has a substantial energy intake, and it's an order of magnitude greater than metals, greater than glass fiber. And we see that as a real challenge. So as we see our customers design blades to be more sustainable in the future, we think using higher modulus glasses is the way to do it, to reduce the carbon emissions, or the embodied carbon of the blade, essentially. And how do you reduce your amount of carbon fiber to the exact amount you really need in your blade structure, and supplementing it with higher modulus glasses, either in hybrid spar cap designs or in shell and root segments in a structural design. That's how we see higher modulus glasses continue to play. So I think that's it for the time that I have. So I want to thank you all for joining and listening to us today. And please reach out if you have any further questions or want to contact us in any way. Thanks, everyone.